If you come to the conference in person, you don't know who you're going to bump into in the hallway. You don't know exactly who you're going to run into at dinner, who you're going to end up sitting across from at the lunch table, but they could be your future collaborator, your future colleague.
It's not a talk. It's not a talk yet. So the disclaimer for this talk: I'm going to interact with you guys, and I also need you to assume that we are on the latest standard on the C++. Let's start. So Ruslan working for Intel. For Intel, let's go for a talk. I have a code here, Lambda. Then I'm copy constructing this Lambda. Then I'm assigning this Lambda. What's wrong with this code in C++ 23? Quickly, somebody. Okay, nothing is wrong with this code. It's just cool. It's just amazing code. Now I have the same code that I have Lambda with capture. What's wrong with this code? Like Lambdas are not assignable. I cannot assign them if they are with capture. Now I explain it why it matters for from my talk perspective. So let's talk about trivially copyable. There are lots of things here, but what you basically need to know about trivially copyable is that your class type is trivially copyable if you have at least one eligible default member, like copy constructor, move constructor, copy assigned, move assignment, and of course, it should not be deleted. The rest might be deleted, or if they are there, they should be trivial. Of course, it shouldn't have. It should have non-trivial, non-deleted trivial destructor. And the members, but we are talking about like operations here. Okay, now we learned it. Is this Lambda trivially copyable? Yes. Yes. Is this Lambda trivially copyable? No, because sorry. Who said yes? You are cool guys. I made my mistake. Yes, because we have deleted copy assignment. All that are eligible are trivial. All that are not eligible, deleted. We don't have any user provided. It's trivially copyable. Cool. Now we go to ranges. I have a Lambda, I have a vector, I pipe it with state transform. Is my view, decal type of my view, if this type, is it trivially copyable? No. Yes, it is. It is trivially copyable. But if I change it to like the Lambda with capture, is it still trivially copyable? Sure, why not? No, it's not. And the point is, we will see in a minute. That's how we define our, I think most of our views in the standard with this movable box. This is exposition only, but it should operate like that. It should try to provide copy assignment operator even if your callable is not assignable, which gives us a basically non-default provided operator assignment. For move, it's the same. We're only talking about copy. It doesn't matter for the purpose of this talk. So we have it, and it basically tries to use copy constructor to perform an assignment. If it's copy constructible but not assignable, it provides this, but it makes it non-trivial. And I hate it, honestly. I explain in a minute why, but that's basically what I wanted to show. Like, we just violated this eligible copy assignment is trivial. It is not. It is provided by this class. The fix is simple, right? We can just stop using lambdas. Cool. Let's go back to C++ 98. Of course, I don't want my users to write this code. I want this code to use exactly like this. And when it matters, actually it matters for heterogeneous computing when you want to offload to accelerator. So basically, if you have some hetero policy, which is, oneDPL had such, as our parallel algorithms implementation, NVIDIA Thrust also does have such. You want to copy your range, your data, without a lot of details. There are some corner cases. but you want to copy it to accelerator. And if it's trivially copyable, you can just copy it to accelerator. That's what you want. That's why it matters. So what I'm personally going to do about it, I'm going to write a paper for the next C++ meeting, I hope. Don't steal my idea. I'm going to do this. To basically say that if the Lambda has a capture, I want it to be, its assignment operators to be equal default, not equal delete. I did my research. I haven't found any reason why it's not like that today. If it, like, you know the reason, talk to me offline, please. I'm very curious. But that's the plan. That's my talk. 5 minutes, perfect timing.